All right, let's do this 4.4, continuing, talking now about reference angles. What are these things called reference angles? We let theta be a non-acute angle in standard position that lies in a quadrant. Its reference angle is the positive acute angle, angle prime, or theta prime, formed by the terminal side of theta and the x-axis. So we're going to be making all of these based off of the x-axis and some line that goes away from it. This reference angle is helpful because as we move forward, we may want to simplify our work instead of rounding all the way about, in this example, going past 180 degrees, really just look at what this triangle here would be and decide what the signs are going to be based off of that. So this is helpful because we don't spin our wheels as much, rotating around and around and around to get where we need to be. We just do it in a more simple fashion. So what we can do in this case, if we're dealing with a reference angle and it's greater than 360, we can just use the coterminal angle, believe it or not. So if it's 360 or greater, then we just cut it down to size, just keep deducting 360. So 580 minus 360, because again, this is more than 360. So we keep cutting it down. This gets us down to 220. And now we're kind of stuck because this is less than 360 and greater than 0, but not quite the acute angle that we needed. So sometimes a quick sketch is helpful here. So I know that with 220, that's going to go counterclockwise to 180. Then it's going to go a little bit more to here. And so what's the difference really between the 180 and the 220? You should be saying 40 degrees. So in this case, 40 degrees would be considered our coterminal, or sorry, our reference angle. So not quite the same thing as a coterminal angle, but if it's more than 360, you can kind of treat it like that. So remember that we want our reference angle to be acute. Like, oh, it's acute angle, it's less than 90 degrees. That's the case here. So let's do this one more time. We have 8 pi over 3 dealing in radians, but that's okay. So let's deduct 2 versions of that pi. And if we're dealing with fractions, we can treat this as if we're subtracting 6 pi over 3, which gets us to 2 pi over 3. If we were to map this out, we would have pi over here, but we're splitting this top part into 3 congruent slices. Disregard this because this is the y-axis. So let's map this out. If we were to map this out, we go past one version, we go past the second version, and so our angle down here is going to have to be that missing pi over 3. So that's our reference angle. Let's do the same thing with here. Now this is negative, and that's okay because we can just add back 2 pi until we get to that interval that's less than 360. So let's add back. Let's do negative 13 pi over 6. Let's add on 12 pi over 6. That gets us negative pi over 6. So not quite where we need to be, but that's okay. We can keep going, map it out. Honestly, if you map this out, you would get us pretty close to what you need, but we'll keep going anyway just to keep it positive. So negative pi over 6 plus another 12 pi over 6 gets us to 11 pi over 6. So let's map that out. If we have this, let's map out 6 intervals now. 1, 2, 3, 4, 5, 6. Let's sketch this down. Okay, now let's keep going until we hit 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That means theta is going to be in here, and this is a difference of pi over 6. So pi over 6 in this case is our reference angle. We can take this further and actually solve for exact values for select functions. So recall that if it's greater than 360 or less than 0 degrees, we use coterminal angles to get there. So negative 17 pi over 4 is definitely going to be more than that if you were to convert it to degrees. So Let's add some intervals of 360 back. So let's plus 8 pi over 4. That gets us negative 9 pi over 4. So we're not there yet. Negative 9 pi over 4 again. Let's add back 8 pi over 4 more. Yep, keep going. Add on more. So 7 pi over 4 is where we should be mapping this out. So let's do that. So let's draw again xy plane. Let's break this up into 4s. Let's keep going until we hit 7. So 1, 2, 3, 4, 5, 6, 7. So our difference here is going to be pi over 4. So let's separate this. So now if we're finding the actual value, this has a little bit more to it because we want to be careful with how we pinpoint our sign, because recall this is negative. So in here we have pi over 4, which in this case I'm going to rewrite as 45 degrees. Down here 45 degrees. This is a right angle. Keep this as 1. All right, so recall that if we're dealing with a 45, 45, 90, our hypotenuse is always 1, and then our sides are always square root of 2 over 2. But keep in mind this is negative, so this is a negative change in y, so we'll make that negative. All right, so secant is going to be 1 over cosine of theta. Cosine of theta is going to be square root of 2 over 2. And if we flip this, this would get us 2 over root 2. But then we can rationalize it, so this should be the following. Our denominator we can rewrite as just 2. And this is all over with 2 up top, so this is equal to root 2. So square root of 2 is for this one. That's our value. And I'll even double check it. So I kept adding back. I try to get my reference angle, which was 7 pi over 4 at first, but then if I looked more closely, it was pi over 4. And I knew that my x-coordinate was positive. Our downfall here was negative. I was going for cosine, which was adjacent over the hypotenuse. And I was flipping that because it's dealing with secant. And I think that's it. That looks about right. If you have any questions, let me know. Thanks for watching.